In this work, we present a valve turning task where we predict axial misalignment between a gripper and a valve from the reaction torques that are produced at the base of the valve. When we look at some of the activities that we perform daily, such as rotating a doorknob or twisting a bottle cap, these tasks involve rotation of the hand about a fixed axis. In tasks like valve turning, misalignment can lead to high reaction torques, which can cause damage from excessive force, so it is important to correct this. We present a scenario of a gripper rotated about the horizontal axis with contact forces F1 and F2. The reaction torques at the base of the valve in terms of tau x and tau y are produced as a result of these contact forces. At this point, we introduce the torque space, which will contain the axis misalignment information in terms of the reaction torques. As the misalignment varies, tau x and tau y in the torque space will vary. We model the elastic interaction between the gripper and the valve as two springs with stiffness K. To model the small misalignments, we select n1 square plus n2 square to be less than 1. And given the compliance at the contact points between the fingers and the valve, any inconsistency will give rise to strain energy. We then solve for the equilibrium condition, which means that tau z is equal to 0. And using the same condition, we solve for tau x and tau y by taking a cross between the contact points and the forces. The gripper configurations with corresponding reaction torque ellipses are shown here. We vary the misalignment in simulation along the horizontal axis, which means that we are varying N2. And we characterize these results obtained with three key observations. The first, that for every single turn, there are two loops in the torque space. The second, that the length of misalignment vector is proportional to the diameter of the ellipse. And the last being that the misalignment vector is tangent to the torque ellipse. For the experimental protocol, the robot was manually guided towards the valve in high compliance mode. The gripper was then closed and the joints of the robot were allowed to adjust to minimize the torques, again in high compliance mode. After this, the gripper rotates and the robot settles in low compliance mode. These are the reaction torque plots obtained from the experiment, which validate the three geometric features which were talked about earlier, very similar to the simulation results, and we can say that under quasi-static assumptions, axial misalignment can be predicted from the reaction torques.